Okay, so in this video I'm going to have a look at the Junior Cert Higher Level Maths Paper 2 for 2017, and here I'm going to just have a look at questions 7 and 8. So question 7 is about Rosie and Gary. They're out for a walk and decide to estimate the height of a local tower. They have no measuring tape, so they can use one of Gary's shoes. They measure the tower's shadow and find that it is 30 shoe lengths long. They measure Rosie's shadow and find that it is 4 shoe lengths long. Rosie knows that she is 140 centimeters tall. Use this information to estimate the height of the tower. Give your answer in meters. It might be useful to draw a diagram. So what we're going to do is draw a diagram here of the tower first of all. So this is the tower along here, and this is the shadow along here, and this would be, the sun would be up here, it would shine, it would hit the ground, the end of the shadow is out here. So we end up with this triangle here, and we know that we want to find what x is. We want to find the height of this tower here, and we know that the length of this shadow here is 30 shoe lengths. Call it shoe lengths here. Now we also have Rosie here. She's a lot smaller here, so she's going to look something like this. We know that her shadow is 4 shoe lengths long, and she knows that she is 140 centimeters tall, so 1.4 meters. Divide by 100 here. We keep everything in meters because we need our final answer in meters. So the distance from here to here is 1.4 meters. Both these triangles that we've drawn are right angle triangles, and because the sun is in the same position, the shadows that are drawn for the tower and Rosie here, they form these two triangles, and the two triangles are actually similar triangles. In other words, we have two 90 degrees here. This angle here is going to be the same because the sun hasn't moved, and this angle here is going to be the same. So we have similar triangles here, and because we have similar triangles, we can use the theorem that for similar triangles the sides are in proportion, corresponding sides are in proportion. So in other words, we can say here that x over its corresponding side 1.4 is going to be equal to the side here, which is 30, over its corresponding side, which is 4. So if we just cross multiply here, we have a fraction equal to a fraction. We can say that 4x is equal to 1.4 times 30. That will give us an x value here of 1.4 times 30 divided by 4, divide across by 4. So if you do this, you'll get an answer of 10.5 meters. So the height of the tower here is 10.5 meters. This is the height of the tower. Give your answer in meters. Okay, that's it. And we've drawn two diagrams. That's it. Okay, so next part of this question then, well actually that's it. I thought there was another part. There isn't. We're moving on to question 8. So question 8 here involves this shape here. We've got two triangles that are connected, and they're both two right angle triangles. So we have a right angle here and a right angle here. We have ABC, so ABC is this triangle here, and we have ACD, which is this triangle up here. AB is equal to 10, AC is equal to 12, AD is equal to DC. So this distance here and this distance here are the same. That's going to be useful. So this value is x, this value here is x. That's an isosceles triangle. The angle BAC is marked y. Use trigonometry to find the size of the angle y. So we've got to find this angle here. Give your answer correct to one decimal place. Okay, so let's do that. So we're just going to use this triangle here. So let's just draw it first of all. I'll just draw it separately to get rid of any other bits of information that we don't actually need at this stage. So we've got 12 and 10, and we've got to work out this here and this here is a right angle. So we've got to use trigonometry. So if we look here, our angle is here, we have an adjacent and we have a hypotenuse, so that's going to indicate that we're really going to need cosine here. Cosine of y is going to be 10 over 12. So if we have the cosine, we want to work backwards to find what y is. What you do is you use cos inverse 10 over 12. That you can just type into your calculator, and you will get y then equal to 33.5573 and so on. Now it says give your answer correct to one decimal place, so I'm going to say y here is going to be equal to 33.6 degrees to one decimal place. Okay, so now we have y. Find the value of x, give your answer correct to two decimal places. So x is here now. We have a right angle triangle here, but we only have one side. We don't have any of the angles, so how do you do that? Well, I'm going to use Pythagoras' theorem here. Now normally you can't use Pythagoras' theorem if you only have one side, you can't use Pythagoras' theorem, but because these two sides are the same, it will work out. So let me just draw it here just to show you what I mean. We have a right angle triangle here that looks like this. We have an x here, we have an x here, and we know that this side here is 12. I've rotated it, but I mean that's what your triangle looks like. So we got to work out what x is. Well, you know that x squared plus x squared is equal to 12 squared. So look what we have here. We have an equation. There's only one unknown there, x, so we can work out what that is. We can work out what x is. So 2x squared then will give us 12 squared, which is 144. X squared then divide by 2, that will give me 72. X then is just the square root of 72. The square root of 72. And it says give your answer correct to two decimal places. So when you do that, you get 8.49. 8.49 to two decimal places. Okay, so that's it for part 2. Okay, for part A, in fact. So part B here involves this circle and this these two triangles here. So let's read down through it. The diagram below shows two different triangles, PQR. So you got PQ and R here, and RSP. So we have RSP here. So you have this triangle here. The points RS and P are on the circle. So these 3 points are actually on the circle, and the circle is called K. Q is the center of the circle, so we have the center here. The angle at QPR is 22 degrees. The angle PSR is marked T. Find the size of the angle T. So we got to find this angle here. Okay. Now, if you look at this here, let's see what we can just write in immediately. Well, I can say here, well, that this is a radius and this is a radius here. So that side and this side here, they're both equal. This is an isosceles triangle. If it's an isosceles triangle, that angle there is also 22 degrees. This is just by looking at the triangle, or looking at the diagram rather, and looking at this particular triangle. So let's see what we need to do. We need to work out what T is. Well, what I can do here is work out this angle here by adding 22 and 22 and subtracting from 180. That'll give me this angle here. So let's do that first anyway. So we can say anyway that angle RPQ is equal to angle PRQ is equal to 22 degrees because they're isosceles. ISOSCELES, isosceles. Because it says show all your workings out here, so we got to say where this has actually come from. Now, from that, then I'm going to work out the angle PQR. So I'm going to say the angle PQR is going to be equal to 180 degrees minus 22 plus 22 degrees. So that will give me 136 degrees. So now I know what that angle there is. Now the reason I'm doing this is because this is the obtuse angle. Now this is the obtuse angle. Because what I'm going to do here is work out the reflex angle. I'm going to work out this angle here. So I'm going to work out this angle here. And the way I'm going to do that is, I know that this is 136. So all the way around is 360. So I'll just actually write that in while I'm at it. This is 136 degrees. So I'm going to work this angle here out by subtracting from 360 degrees. So the angle here at PQR again, remember I've worked out PQR, the obtuse angle. The angle at PQR reflex really is going to be equal to 360 degrees minus 136 degrees, and that's equal to 224 degrees. And this is the reflex angle. So this angle here is 224 degrees. So this angle here is 224 degrees. Okay, so why am I doing this? Well, if you remember from your theorems, if you have a circle, and let's say we have this angle here, and we have, let's say, this angle here. Now this is the center of the circle here. You can see that both angles are standing on this particular arc here. So this angle here and this angle here, they're both standing on this arc. But if you take this point here and this point here and move them up this way, move them both up this way, this angle will get bigger. Both angles will get bigger actually, but you'll end up with this kind of a situation here. You'll have this angle here and you'll have T here, both of them standing on this arc all the way around here. So this arc, they're both standing at the angle at 224 and the angle at T are actually both standing on that arc there. So in other words, we know from the theorem that this angle here is theta, this angle here will be twice theta. In other words, this angle here is going to be double T. It's going to be twice the angle at T. So all we've got to do then is say the angle at T is equal to 224 degrees divided by 2, so that's 112 degrees, 112 degrees. So the size of the angle at T is 112 degrees. And that's it really. So this here is our answer. This is our angle at T. Okay, so that's it for questions 7 and 8.